Welcome, this is Mrs. Azrak and this is the Proximity Game Screencast mini lesson. So let's get started by opening an internet browser window. We're going to type in the web address that was provided to you on the first page of the handout. That's http://ccssgames.com. This is going to open the Data Games website, and we're going to pick the proximity game in the middle by clicking on the play button below it. We're taken to a login page, but we're not going to put a user and password. Instead, we're going to click on the Login as Guest button. The proximity game will come up. There are three screens to the proximity game. There's the main screen, there's a graph, and there's a table. The object of the game is to push the ball as close to the middle of the target as possible. To push the ball, you have to click on the ball, drag with the mouse, and hold the button down. And then when you release the mouse button, you release the ball. As you click and drag back, notice there's a number. That number is the number is the magnitude of your push. The further you pull back, the larger the number, the larger your push. Now, if you pull back too far, you're going to basically end up bouncing off the walls. Now, your table gives your push information, your distance. This information is also graphed for you. You should be able to answer the first two questions on page 5 of your handout. What type of correlation do you see in this graph? We've been doing correlations for a while, so I hope you're able to answer this question easily. The second question might be a little more difficult because of the ball that bounced off, but ignore that point. If you just look at the other points, what model would you use? Make that decision. I think you can make that decision quite easily. Now notice it says click the ruler to measure the distance. If you click on the ruler, you can click on the ball and drag while holding the mouse to the middle of the target, and that will give you the distance between the ball and the center of target of 107. With 107, you can use the information in your table or graph to make a pretty good estimate for predicting how much push you'll need. Now I got a score of 188 on this first dock level, and if you click on the levels button, it will tell you the requirements to get to the next level. To get to Sneezy, you need 500 points on dock. To get to Dopey, you need 425 on Sneezy and 2 in a row. And that's going to be our goal for today. We're going to try to open the Dopey level at least. So to close this window, click on the X. Now there are a few things before you start play. One is when you need to do a new game, you click on the New Game button. The other thing is you're going to want to fill in your scorecard in your handout. You're going to put the level and your score. Now hit pause on the screencast and go play proximity game. Don't forget to record your results, and after you've played the game 3 times, come back to see the next part of the screencast. Have fun! Now if you haven't gotten to Sneezy, don't despair, because the algebraic representation can help get you there. Now, to get a line and an algebraic representation on the graph, click on the gear in the upper right-hand corner of the graph and select the second item in the menu that says Show the Movable Line. Now you're going to want to drag the line by holding the mouse button down and moving the line. As you do this, you can see the equation, the algebraic representation, changes as you drag the line. So I get a formula of distance equals 9.91 push plus 3. Do you recognize this algebraic form? We've seen it quite a bit while studying linear equations. It's the y equals mx plus b, where m is the slope and b is the y-intercept. So if we click on the ruler and we measure between the middle of the target and the ball, we have 156. And that's our distance. So if we know the distance, we can figure out the push and actually estimate it by just dividing by the slope. Now to do this, we'll need the calculator. So in the toolbar, click on the calculator icon and the calculator comes up. Now, if we divide the distance by the slope, 9.91, we get a pretty good estimate for how far we'll have to push the ball. And now that you have an algebraic representation for your data, you can pull up the line and get it for each game. You should play the game some more. For this second part, use the Part 2 scorecard in your handout. So on the scorecard, you're going to want to fill in the level, the score, the equation, where here I had y equals 9.91x plus 3. And then write that my slope was 9.91 and my intercept was 3, and I opened the next level. Now continue to play the game till at least you've opened the dopey level. If you make it to the grumpy level before the end of class, have your game verified and you will receive an extra 10 bonus points. Don't get frustrated. If you do, check the mini lesson blog. I will provide you some extra clues there to help you along. Remember, for tonight your homework is to answer the questions at the end of the packet. Come prepared tomorrow to discuss the approaches you used in class. This is Mrs. A, and I hope you have a great, fun-filled day of learning. See you tomorrow.